you're like a god, God's explanation, God's process of creating human
Oh,
species.
God's on you. Sometimes I talk about.
Oh, are you talking about the Adam and Eve thing?
Yeah, yeah,
I
Adam
didn't
and
get
Eve,
a
yeah.
chance to.
Oh, you looked at my Adam and Eve code? Oh, I'd love to talk about that. Yeah, yeah, yeah.
Yeah, yeah. I'm interested to hear from you how you use par when you send on par.
Yeah, I'd love to talk about that. Totally. But before we
That's
dive in, I wanted to just tell everybody that I invited Glenn Braun, who it looks like is on the call.
great.
Glenn is writing a cool piece of software called JSON Pi, and Glenn, you can tell as much or as little about it as you want as we go through here.
Hi, Glenn.
Hi guys, good to see you all again and meet some new people here too. Yeah, I'm working on, just quickly, it's called JSON Pi. It's a Pi calculus plus functional programming language that the language is expressed in JSON, and any name from a Pi calculus perspective is any valid JSON.
Cool.
And
so with PyCalc, you have to inject a set of names, right? And the set of names that you chose to inject instead of any string or any number was any valid JSON.
Right.
String, I guess, right?
Right. So the row calculus says that any name is any process, right? It starts out with the empty process, then the next name is maybe the empty process par, the empty process, and so on and so on and so forth. So you build up names out of processes. JSON Pi is kind of the opposite. It starts where any name is any valid JSON, and then a process is just some of those JSONs. So basically, it's just the abstract syntax tree of a language expressed in JSON. And so that way a process is a JSON object, and of course any JSON object is a name. And
yeah.
So that's the idea.
So okay, so imagine I write down some random string of characters. There's some chance that that will be a valid JSON string, not particularly likely, but if it is, then it's a valid name in JSON Pi. And if it is a valid name in JSON Pi, there's some subset of those names which actually are JSON strings that represent valid processes.
Right.
Yeah. Cool.
I could give I think I can give a just very tiny example of what I mean by these.
Let's look at Adam Eve, and then we'll look at yours, and then I think Isaac had K framework. So I will go quick here. I definitely want to answer Tomislav's question at least. So, well, actually, I don't even want to start with Adam Eve. I want to start with this one. I think this word is pronounced queen or quine. I don't really know. But it's a QUIN is supposed to be a program. Traditionally, it's a program that when you run it, you don't give it any args. It just prints out some output, and the output is the source code of the program itself. So in Rolang, I had a little bit of a different concept where instead of outputting the source code, it actually spawns off a new process where the new executing process is the same process as originally. And I did this, it's really, really similar to how I wrote an actual QUIN in Python. And so
wait, can I ask a question real quick?
Yeah, totally.
So is that different from like encoding the replication operator?
That's a good question. That's a really good question. I was definitely thinking about replication, and the Adam Eve code, this whole folder is even called self-reproduction.
Yeah.
So
okay.
I don't, that's a great question.
Okay.
So this all is just a send, right? I made some channel called self-chan. On self-chan, I send some long process, right? We'll get back to what the process I sent is now, but just notice all I'm doing is sending some process on self-chan, okay? Line 13 is where more interesting stuff starts happening. So whenever I receive a message on this channel called QUIN, and this is like the external stimulus, right? This is someone coming along saying like, hey, you self-reproduce. So someone sends a message on QUIN to do that. At the same time, it takes not only that stimulus message, but also it takes whatever I had sent on self-chan earlier. It takes this process, whatever it does, which I haven't told you what it does yet. It gives me a little bit of output just to make sure things are running the way they expected to. It sends the exact same thing that it pulled off self-chan back to self-chan, just so that that channel isn't depleted. And finally, it runs whatever it pulled off a self-chan. So here's the sort of mind-bending part, right? Like the only question I haven't answered is, well, what the hell did you send on self-chan? And what it was a copy-paste of this, right? So that code that I just explained, I sent it on self-chan. And so then, like, when someone pokes this thing and says, hey, you reproduce, it grabs a copy of itself off that channel, puts the copy back to make sure there's always another one to be grabbed, and then, like, spawns this new copy of itself. So I thought that was really cool and really elegant. And I was like, all right, so how can we do this a little bit differently now? Like, for example, what if I wanted to have a process that when you poke it, it's like that thing from Greek mythology where you cut off the head and 3 heads grow back.
The Hydra.
But, oh, Hydra, that's what that's called?
Yeah.
Oh, cool. That's not so hard, right? I just run self 3 times in parallel here, right? So, all right, I could do that. I didn't, because it didn't seem as interesting after I thought about it. So here was my next thing. What if I wanted to do a little bit more like how biology does it, where instead I take 2 parent processes and together, if, you know, some certain conditions are met, then they can breed another, like a child process. And so it was a lot harder than I thought. After I did the QUIN, it was going to be kind of trivial. So I stuck with perfectly mimicking like biology. And so here's how it works. The main contract up top here is called species factory. And when you call species factory, it creates a brand new species and it gives you back 2 things, which you can tell by the names here are like origins, right? I call them Adam and Eve. So there's 2 original items that you get back every time you create a species. And then from there, what we want to do is you know, see if we can breed them, basically. So this is like adult themed Rolang code. NSFW maybe. All right, so here's the part Tomislav asked about, and this is an idea that I stole from Mike Stay that I think is super cool. What I give back, you know, so whoever creates the species passes in an Adam channel and an Eve channel, and what they're expecting is they're going to get Adam and Eve back over those channels. So what do I actually send back over those channels? I don't just send, I created an Eve ID and an Adam ID, which are like unforgeable names that uniquely represent those individuals, but I didn't just send those unforgeable names like we frequently do. Instead, what I sent was a slightly more complicated process. So this par represents Adam. It's Adam's unique individual ID, but it also contains the species ID. And the reason that I'm doing this is because I don't want human Adam to breed with monkey Eve or whatever, right? We only want processes of the same species to be able to breed. And the way we're going to achieve that is when we try to breed 2 species or 2 individuals, we make sure that they both have shared lexical scope over this unforgeable name. So if they both have access to the same species ID, then they're of the same species, and so it's safe to go ahead and breed them. My comment here, oh, Kayvan, this is actually the bug that we had talked about a little while ago. My comment here is that what I really want to do is send a bundle of this par. And what that means is that like whoever's creating the species and getting back Adam can't rip this par apart into its 2 constituent parts. Because if anyone obtains the species ID by themselves, then they can basically like violate some of my invariants. You know, they can create their own Adam or Eve or some mutant that like, what I ended up doing here is that females have 2 X chromosomes and males have an X and a Y. And so like, if someone were able to extract just this unforgeable name by themselves, they could create like a YY, whatever that would do. I mean, it might be pretty interesting, but it's not what I'm trying to do right here.
Okay, can you put just species ID in the bundle? Because I have a question related to your question about bundling and destructure.
Oh yeah, sure.
If you cannot destructure some process,
yeah,
how can you be sure that when I send you my process, how can you be sure that it's not doing something, you know, stealing your private data? Or...
Yeah. How do you know it's not malware?
Yeah.
Oh, Yeah, okay, that's an interesting question. This particular process is not intended to ever be run. You as a user, if you're following the docs, you're never going to run it. But yeah, I mean, if you choose to run it, that's a great point. You don't really know what it's going to do. Oh, well, actually, that's an interesting question too. Like if we think about blockchain context here, you can see what that thing's made up of, right? If you just look into the blockchain through a block explorer or something, you'll be able to see that I gave you a par of 2 unforgeable names.
Right.
But
Yeah, I already asked you about bundling, because I'm thinking that we should always have ability to destructure everything, right?
I don't know. If we have the ability to destructure everything, then I'm not able to do this thing where I give you both, where I say together these things make up Atom, but you're not able to extract the species ID individually.
But if can you make a species ID in the bundle, just species ID inside the par?
Mm-hmm.
Is this enough?
Certainly, it's valid syntax, and the code would still run, but
no one can read from this channel. Or
oh,
is this? I'm asking you: is this enough to protect it?
Well, I don't think so. It is an interesting idea. So I certainly can give you like bundle 0 of species ID paired with, Atom ID, or maybe bundle 0 of Atom ID or something like that.
Mm-hmm.
So then you can destructure. You can get either of those bundles by themselves. You cannot send or receive messages on it.
Yeah.
But sending and receiving messages on just the species ID or just the Atom ID is not part of this. Like I haven't made any assumptions that will or won't happen in terms of how these organisms interact with each other. The thing that I don't want you sending messages on is this highly structured thing here, or more highly structured thing, where it's actually a par. So if you're able to somehow send a message over this par, then that's, when I didn't intend you to. Or, for example, if you're able to send a message over species ID paired with some new unforgeable name that you created on your own, that's an invariant that I assumed wasn't true.
Mm-hmm.
And you are saying you cannot put this in a bundle?
I'm not saying you can't. I'm saying it doesn't achieve. Oh, you mean, I see what you're saying. Like right now, if I were to type bundle the way I'm describing that would happen?
Yeah.
Yeah, there's just one little bug that prevents it from working all the way through. And here's I can't type it right now. Basically, let's see. I think I have VS Code here. Tomislav, I recently got VS Code in Windows. I'm going to try out your extension.
Oh, cool. It should work. I had some bugs, but now it's stable.
Nice, good. So imagine I have something like this.
But you must save the file as a raw extension.
Okay, yeah. I don't even have it installed yet, but
okay.
I'm going to play with it later. But here's a simple example of what I want to do. Imagine I send something on pparq, and then I have this for, like whatever, I don't care what the message is. And the channel I want to take it from is this bundle of p par q. Then whatever, who cares? This should be as far as I understand, that should be a COM event, but currently these don't COM. And so
the bundle is only on the p.
In this case, the bundle's only on the p. Yeah, I haven't yet introduced you to what's going to play the role of q in the Atom Eve code.
Okay.
So because this isn't reducing, I've just instead commented in here, like, really, this should be a bundle. And for now, to make it work, I'm just going to be honest and not try to destructure those and attack that way.
Yeah, I don't think they're going to change that, Jeremy. I'm sorry, Josh.
That's okay. Yeah, Joshy. That's okay. It works totally. It works, fine as it is for now. And we're talking about other interpreters, so we have some freedom now.
Yeah, cool.
And in your example that you write in VS Code, you put bundle just on the first element. But
that's right. So
you could also put bundle on the whole part.
Yeah, I would. Right. My hope is that eventually also this kind of stuff will reduce. Whoops. that should reduce to.
Oh, you want that to reduce?
But you want to do this when you're sending, right? Not when you're receiving. Or
Isaac's question was, oh, you want this to reduce? And for that one was yes, but Tomislav, I didn't quite get your question.
I was thinking that you put the bundle when you're sending P and Q, not when you're receiving.
Yeah, right. So like if I would also want it to reduce if we had this bundle. I got to be careful not to get my brackets mismatched. But yeah, like I would also hope that it would reduce in this case.
And
okay.
you're saying this is not working now.
That's right.
Well, the latter case would work, right? If you have bundle on both lines, that would work.
That would certainly work. Yeah, absolutely. If you have bundle on both lines, this should com, and it does com.
Yes.
Okay.
Yeah.
Okay.
So maybe this is a really stupid question, but if you were to like take away bundle from either of those lines,
Yeah.
I mean, my understanding is that you wouldn't want it to com because you can't destructure that bundle. So how does it know that inside it's like a par of two things? Or maybe that's just wrong, what I'm
So
thinking.
you're saying, is this the example you're talking about here?
No. So like just bundle on one of them, and the bundle contains the par.
The bundle contains the par. Yeah, right.
Yeah.
So the semantics that I was hoping for, and I can give you the link to where Stay had written this up. That
Oh, great. Yeah, that would be cool.
Was that I can't use pattern matching to detect like, well, okay, it doesn't make much sense in this case because like I haven't even sent the bundle anywhere.
Yeah.
So like imagine, well, let's just do at X send like bundle of P par Q.
Yeah.
Okay. And then, down here, I get like for A par, well, it's got to be a name at A par B from at X.
Yeah.
So in this case, I don't want a com because I don't want to be able to destructure and match A to P and B to Q.
Yeah. That makes
So
sense.
certainly that I don't want. Here, though, the question is not whether I'm actually trying to do the destructuring. It's the bundle here is playing the role of the channel, the X, right?
Right.
And so basically, like, we always want to say P par Q par R is structurally equivalent to P par R par Q, and there's other permutations that are also equivalent. And then the semantics that I want to add is, well, bundling would certainly prevent this kind of destructuring that we're talking about here.
Yeah.
It doesn't mess up structural equivalence. So like I could put a bundle around just the R or around just the Q par R or just the P par R or whatever. And those would all still be structurally equivalent, and thus we would still get comms across them. So that's just the like.
Yeah. Right. Okay. So
people don't want to have the same ideas, but
yeah, since those processes are structurally equivalent, then as names they're name equivalent. So we want to come across that.
But when you bundle it, you're basically wrapping that structure into something else. It's kind of like, integer one and option integer one. They're not necessarily the same thing.
Yeah.
I totally agree. And so there's different valid calculi that could be made with either semantics, and it's a totally valid choice to not have these be the semantics. These are just the ones that I'm hoping for and writing against.
Yeah, so you're basically just hoping that like introducing bundle anywhere inside the process that defines the name doesn't change the name basically.
Right. And so maybe I'll skip the details of how these things reproduce and everything, and everybody can check them. But the punchline, the reason that I care about this is because it allows us to do a Diffie-Hellman-like thing. So imagine we've got this bundle. Well, I'll even use the Diffie-Hellman names. G par A. So that's some bundle right there. This is something that Alice created and sent to Bob. Par B. If that, escape. Okay. If that's somehow structurally congruent to G par B par A, where G is the common base, A and B are things that were made up by Alice and Bob, they can exchange this G par A and G par B over a public channel, no one, because they're bundled, no Eve can extract A and B, and now Bob and Alice have a channel over which they can communicate privately. And so the way it works in the breeding thing is, this bundle is just like, this is Eve's identity, right? It's the species ID paired with her ID. And this bundle is Adam's identity. It's, you know, species identity paired with his identity. So when we try to breed them, they make this Diffie-Hellman-like channel, this one right here. You know, Eve expresses to Adam that she's interested in breeding by sending this. Adam creates the big thing by, you know, pairing his ID together. Eve already knows Adam's name, so she creates a contract that listens on here. And so basically, if it turns out that the thing that Eve said, hey, I'm interested in breeding to, is a member of the same species, then they have a common channel. And so that's where the DNA swap can happen. So.
And
That's pretty awesome.
and you're saying that you should not be able to destructure A and B. But as I understand a bundle,
Yeah.
you're saying this you cannot do some operation on this bundle processes, but you should be able to destructure, because you know you can take A, but no one will believe you that this is the right thing you can do, because this is the bundle. You know what I'm thinking, that you can send someone your result of your execution, but all the other validators will be saying, okay, but this is not the correct program. You're cheating. Because this is the bundle.
Say it one more time. What was the scenario from the start now? I'm a validator.
Yeah, so you have a bundle of G and G par A.
Okay, so
And
I, as a Rolang programmer, have created new names, G and A, and sent this bundle somewhere, right? So
yeah,
new GA in XBang bundle G par A. Okay.
and for example, you have some receiver who will destructure the bundle and send something on A, for example, or use this A.
Okay, so this is certainly something we want to avoid, and Co-op's current implementation does avoid this.
But well, I'm saying that this you can do this, but you cannot send this result to anyone, because it's not a legal way of.
What do you mean by can? Are you proposing an alternate calculus that you think is interesting, or are you saying that Co-op's implementation is doing this?
No. I'm saying that I don't see the problem why you should not be able to destructure a bundle.
Oh,
because I see bundle, because you explain me what the bundle is, because I was thinking that bundle somehow hides something inside. But you said that the bundle only is like a label that says, okay, you can do only reading, but you cannot write to this channel. So
there's two parts that are mixed kind of together. That's what so all I've described so far is the part that prevents destructuring. If I make it a bundle plus, now it prevents destructuring and you can only write on it. Or a bundle minus prevents destructuring and you can only read on it. So they kind of glued them together into one syntax.
Oh, so there is only, when you say only a bundle, you cannot destructure. This is what you're saying.
Only bundle, like I've been saying, means you can't destructure, but you're still free to read and write on the channel. Yeah.
Oh, this is valid, Roland, now.
This is valid co-op Rolang, absolutely.
Okay. Oh,
yeah. Or this particular thing right here, it won't reduce because we tried to destructure a bundle.
Yeah.
Yeah.
Oh,
or it might reduce in such a way that A equals bundle of G par A and B equals nil or something like that.
Oh, yeah.
Oh, yeah, like when you destruction part.
Yeah, right. So
I see.
Yeah, but so like another interesting use of this Diffie-Hellman pattern is when you're moving coins around. Like if I'm going to take payment from Isaac, I don't want to accept his coins into my wallet until I know they're the same kind of coins. like, you know, I don't want to take his lead coins and think they're gold coins or whatever. So we do this same exact trick where G in this case is like the mint ID, you know, or somehow specifies what coin instead of what species or something.
Yeah.
So.
Oh, that's cool.
Yeah, thanks. I think it's kind of cool too. It's not as elegant as the QUIN one yet, but I just got to think a little bit more. So.
Yeah, that's awesome, man.
All right. So I don't know. You guys want to? Should we listen to Glenn on JSON Pi for a little bit and then move from there?
I definitely want to see that example of the JSON Pi.
Yeah, cool.
I was wondering if you give me a little hint on a match statement here, which is holding up, releasing voting. It's writing a message to a mailbox, and I want to get if it's a list and it's of, I want to capture the type, where the type is equal to the message, the first element of the message, and the subtype is equal to the second element of the message. Can you give me a hint, and then we'll move on?
Hey guys, I'm gonna head out.
All right, cool. Good hanging, Jay.
Take it easy, man.
See you next time. Okay, so so you told us what you want to do. What's the happening or not happening?
Well, I'm not able to get the syntax correct.
Oh, it's giving you a syntax there?
You know, I tried various things, but
so it looks like you're trying to map against a list that's exactly 3 elements paired with maybe more stuff.
Right.
Okay. So what character is the syntax error?
But can you write just par more in this is the end of the list. Okay.
Yeah, it's at this brace at 22 that's highlighted.
Oh, it's the problem, Jim. Give me the screen share back for a sec. It'll be easier to show than tell.
Do you need to put all of the match inside the? Braces?
Here's the wrong way to do it. You know, you can say like at something.
You want to share?
Josh, can you share?
Oh, sorry. I'm sorry. I thought I was sharing. That's embarrassing. Okay. So I think this is what you tried that's not quite right, where you wanted it to match, you wanted it to be at nil let's think of a better one to do, like at int and at 4, or I don't know, like that would match the number 4, right? Here's the right way to do it. You want to do at, and then those connectives can only be used on process patterns.
Mm-hmm.
Something like that.
Yeah. Yes. So then each element of the list should be at with like curly braces surrounding the whole and
right.
statement.
So yeah, exactly. So Jim, you had a list par more, and then it was a 3-item list. Let's see if I can make that bigger.
Right. I want to.
What you want in each one is at, and then I don't remember what you want. It was like type and what was the other thing?
Yeah, it was like message dot zero. Yeah.
And then similar here at.
Yeah, subtype.
Yeah.
Yep.
And
message dot nth of 1.
Messages dot nth of 1. And then I don't know. I forget what the last one was.
It was like something with set. Yeah.
Thanks, guy. Let's move on to Glenn's.
All right, no problem, Jim. I hope that helps you out, man.
Hopefully I can get it right. I'm struggling with it. And I just need to learn.
All right, Glenn, you want to show us your stuff? Nice. Started screen sharing.
Oh yeah, great.
Can you see my screen?
Yeah.
Just a little.
Yeah, could you make it a little bit bigger?
Is that better?
Oh, that's perfect. That's perfect.
Okay, so this is just so the language has a text format, you know, just like most programming languages. but what really runs is JSON, and I'll show you that in just a little bit. So this text gets parsed and then converted to JSON, and the JSON is actually executed or evaluated. So I'll just show you this. You start out with a namespace, and then inside of it you can have, this is sort of like, well, I'm an F# programmer, so this looks a lot like F#. And so it has simple bindings of values. So here, A and B are two new names on top of the string A and B. And then you can define a schema. And what this is so
Glenn, that string, like on line 3, quote A, quote, that's a small but valid JSON string, right? So that means I can make it into a new name?
Exactly.
So if I were to put something that's not valid JSON in there, then that's going to be a like syntax error or something, I guess? Okay.
Yeah, it won't parse, right?
Okay, yeah.
So JSON schema is I don't know if it's a standard, it's a standard that defines a schema language for JSON objects. So it lets you validate a JSON object. So you can say like, okay, this JSON object has to be an integer, or this JSON has to be an array of 2 elements. The first one has to be a string and the second one has to be a Boolean. So it's a type system on top of JSON. So what we have here is that you can also define these. And so here I'm defining a schema that says, okay, here's a process that you can send on a given generic type. And so I'm saying that this schema basically inherits from any JSON Pi process. So a object that validates against this schema must at least start out being a process. Later, it has to be a process that specifically only sends on this type. That's the idea. You then define properties, which has a send.
You're like filtering or restricting something here when you.
Yeah. So what a schema defines is, you can think of it as defining a function that you pass in an instance. So you give it a JSON object, which in JSON Pi is a name, and it comes back essentially true or false. Does it meet this schema or not? You can kind of think of a type system this way. If I give you an integer and you've got in your language that it has to be a string, the compiler is going to say, sorry, this thing that you gave me, this number 5, it's not a string, it's an integer, so it comes back false. This is a little bit of a tough example because you and I, Josh, you were talking about how could we write a program that says that you can't send, that you can only send on a given name, I guess is what I'm doing.
Yeah, Glenn was getting pretty excitingly close to a behavioral type system, and so I challenged him to say, like, can we say that, like, not just that a given process doesn't send on a given channel, but like that it never will, or that it won't reduce to a state that will, or something like that.
Yeah. I'm just going to skip ahead. I'll just keep from a high level. Just understand that in the language you can define a JSON schema, and that defines a function that when I give you an instance, it comes back true or false that it meets those requirements or not. I won't go into the specifics of these requirements. Okay, so here's another schema that says not A, and that's pretty simple here. It just says not an enum of this thing. If you knew JSON schema, this would be very understandable to you. Okay, so with those values and schemas defined, we can then define a thread. And a thread is an array of processes that run in parallel. So so this is, we have 2 processes here. One is a send, and one is a receive or a listen, and these two are running. It's a par between them. So this is process A, and this is B. So we're sending A on B, and then after we, one thing is this is synchronous. So after a send, there's a process that can happen after the send. In this case, it's the empty process. Just don't do anything. On the listen side, you listen on B. So we're sending on the same channel, A and B. So a COM event should happen here. So we listen on B, and what we then have is a set of rules that are expressed here in this when syntax. So when X, that's just a name binding. So whatever came across B is going to be assigned to X. And then we say send something on what we received. And so what we should get is, since this is a thread of type process send on anything that isn't A, is we should see that, oh, wait, it's going to evaluate that you've received A over B, which then binds to X, and so you're trying to send on what will be A. And so you should get a compiler error that, no, this doesn't meet this schema. It does evolve to a state where it sends on A. I've yet to prove that in actual implementation, but I think my schema and such will detect this. Should be possible to detect this. I believe so. I haven't yet proved it.
Yeah, that's pretty cool, man. That's great.
This is in the sense that a thread is like a par, which is somehow parameterized by a type. Can I say something like that?
Yeah. So that's right. In this, where did I? Yeah, that's right. So a thread is a type. A thread is a type, but I'm sorry. When I define a thread, it has to be of type process. I actually have this process somewhere here. Yeah, here it is. So a process has to be one of a send expression, a listen expression, or an inactive process expression. This is JSON schema. But the thing is that, sorry, we could further restrict the process to say specifically it has to be a process, but also it cannot, what it can send on is not A. It can send on everything but A. Let me go to, I'll just show you, if you understand a little bit more about how the language works. So I'm switching to a different example altogether here. This is a simple COM event that I think I'm doing send. So send true on 1, and we'll use kind of a oh shoot, you're gonna get sorry. Let me use a different. Okay, so send true on 1, listen on 1 for when, let's say true, then let's just take that much, then don't do anything. So this is your simple COM event. Send true on the name 1. Okay, and here we're listening on 1, and when it equals true, then do nothing. So this is one COM event. when this gets represented in JSON, so this text gets parsed and it gets represented in JSON. And so what you see here is some JSON that is right. Well, this is a little more complicated example, but here's the send, and the message is true, and the channel is on. Okay, so send true on 1. That's represented in this JSON.
Okay.
So what's the schema? Oh, then. So inside of then is a whole continuation. You always have a continuation. Or you always have a schema inside of every, like,
right. So
thing
this
that
is
you can
really, yes, send 1 on, instead of that, it's send, let's see, what is it? Oh, then listen on 2.
Yeah.
Or I think this does nothing then. When true.
When pattern true, then do
Sorry
nothing.
for all the then and ends. I plan to use significant white space, so you won't have to have all these terminals.
Yeah, yeah.
That's just the way it is right now. So I think then what this does is say when it gets that, then it sends true on 2.
Oh.
Something like that. So it's just a double COM event. One side sends, then it listens. The other side listens, then it sends, and then it should resolve to nothing.
Yeah, cool.
But what I just wanted to show is that how the reduction rules happen inside the JSON. So what we have here is I've got 4. I have the different states. What I've done is run the program and then saved the JSON at each intermediate step of the COM event. So we have state 0, state 1, state 2, state 3, and state 4. And I'll show you how these, maybe it's easier actually to go backwards since it's smaller.
Dude, that is cool that it saves at each step of the way. So you can, like, you've got a trace of how this thing reduced now.
Right. So
Yeah.
so what happens is actually maybe it is education. It's informative to go backwards. So we have our thread, and it has 2 processes inside of it. It's an array of 2 items separated by this comma. So that's a par. And what we have is 2 inactive processes. So basically this thread is done. If we go backwards to how it got there, is it had one of its processes was done. It's the inactive process. But the other one was still in the middle of this sending true on the channel 2. If we go backwards from there, we see that our send was still there, sending true on 2, but we still had our listen on 2, okay? So if we go between these 2, we see that, okay, what happened is this listen reduced. So here's the listen. It's listening on 2, 4, and I know that this is very verbose in JSONs, but it's much smaller just in text. But what we would see is that this listen on 2 reduced. So we heard on 2. And so this whole thing reduced to this. Okay, sorry, it's kind of a verbose syntax, but listen on 2, 4. If we got a true, then go to this. It's a match and a receive at the same time.
Oh, Glenn, can I interrupt you for 1 second?
Yeah.
That's super interesting that it's like processing the sends and the listens kind of individually, because that's exactly the way that I'm doing it in the K framework implementation as well. Because it's basically like parsing the process that I put in there, and then like anytime it detects a send, it just like sends it over to like some cell in the tuple space. Anytime it sees like a listen, it does exactly the same thing, just sends it to some cell in the tuple space. So it's kind of cool.
Yeah, what I what I'm doing is I have a tuple space, if you will, that is, it's actually just an interface. So I hope to just back it with like SQL or any store. I'm doing it in memory right now, but I totally expect it to be a SQL store because it could be really large.
Yeah.
But in your case now you have JSON as a tuple space, right?
Well, so that's true. You're looking at this entire thing as one document, but it's also can be thought of as just an interface, and it is actually implemented that way as an interface. So this whole JSON document could be represented inside of a MongoDB or inside of a
Glenn,
SQL
is this JSON basically like a serialization of what lives in memory when you're running your interpreter, or does it get dumped to file on every like iteration?
So I'm dumping it to file just for debugging and for informational purposes.
Okay, right, yeah.
But the implementation, the idea is that, yeah, you've actually got this namespace, which is this, it's kind of large to show here, but I'm sorry, let's go here. You have this namespace, and that kind of is your whole program. What I mean, it's like self-contained. So namespaces can talk to namespaces, but the namespace is the program, and as the program executes, it reduces from one state to another, to another, to another, and so on. And I plan to build a system that hosts these namespaces as a service, so that you can, it's kind of like, well, I don't know, like you could send these namespaces around because they are valid names, and they could be reduced by any computational platform that accepts these namespaces. So you could send it to a browser, and the browser understands JSON-Pi, and it could reduce the namespace, and then it could send it to somebody else, and it would know JSON-Pi, and it would reduce it to the next step, and so on and so forth. So,
Yeah, cool.
Definitely cool, yeah.
Glenn, I think you're gonna like seeing how Isaac sets up the row calc in K. I've seen your work and Isaac's work several times, but only now that you're both together am I realizing how similar it is. Like in K framework, Isaac sets up a configuration in XML, which is like super similar to how you've done it in JSON here.
I see. Yeah,
Yeah.
I do wonder. The thing that's happening here, I think that might be interesting, is that because the language, let me see if I can say this right. So you actually got it, Joshi, when you said some names are special, they're processes. So for instance, this right here is totally valid JSON. It starts with a curly. It has one, it's an object. It has one member property which maps this string to this value. So it's absolutely valid JSON. So it is a name in JSON-Pi. Additionally, it's a valid process in JSON-Pi because I've defined, actually you can see here, I've got all these different schemas. For instance, if we go here, we'll see that here's a schema that says its type has to be object. Well, it was an object, it has curly brackets. It has, in that object, we can have one property called schema. Well, we do. We have one property called schema. It has to have a constant value of this string. And yes, it has that. And then for a nice, just a handy thing, I give a default. It says, well, if you didn't give this thing, I'll supply it for you. Okay, so that's the default. And then it's required that it has this $schema, right? So what this right here defines is it says, okay, this is a special name. The name, like any other in the whole language, but this one's also special in that it specifically means the default, I'm sorry, the inactive process. So if we go back to my previous example where I defined these schemas, in this case, process send on this type, I could set excuse me, the on type as like inactive process.
Mm.
In other words, you can only send, this is a process that only allows you to send on the inactive process. Anything, any schema that I use JSON schema as the type system. So anything that passes that schema becomes valid. And the big leap, and I don't know, this is something this is what I'm exploring, is does that equal behavioral types?
Yeah, that's a really good question. It seems like just the tiniest bit different than how I had originally imagined it, in the sense that this is basically like when you try to do the illegal thing, then it stops you with a runtime error.
Well, I believe I can actually do it at compile time and say that.
Oh, really?
I think so. I think that the type. Yeah, I think so. I haven't yet proven it, but I believe so. I believe that I can walk backwards and be like, oh, wait a minute. This channel is restricted at that, or this process is restricted that it can't reduce to a possibility where it sends on anything but the inactive process. And I think I can do that right here by saying, oh, we're listening on B, and there's no restriction as to what can be received over B. And so it would just say, oh, well, wait a minute. When I do my type inferencing, I'll say, well, what type can X be? And in this code, since B is nothing but a name, then it means that X can be any value. But down here, but what I've said for this whole process, that it can only send on this type. And so I think I'll be able to detect that wait a minute, X can be of any type. I've got a send operation that's not gonna validate.
So, okay, that's interesting. So it's one thing to say, I have criteria, like, so you've described criteria whereby you could say, like, this thing definitely does not send on A, thus it's allowable, and we'll run it.
Well, I don't know that it definitely doesn't, but I know that it's possible.
That's exactly what I'm saying. Yeah, right. So if I give you some process that legitimately does not send on A, but it looks dangerous enough that the rules you just described detect it as something that might send on A, you know, so there's some level of like conservative behavioral types, right? Where like we can guarantee safety at the expense of, we might also not let you do some things that would have been okay.
Right. So yes. So what it kind of is, it's saying, so for instance, what I would do is I would say, oh, I don't know, this is like channel of, I don't know, inactive, or I don't know, channel of something, channel of int. This isn't the exact syntax that'll happen, but what I'm saying here is that I'll be able to define a channel that says you can only pass integers across it. Okay? And so if A is not in the domain of integers, which it isn't, it's a new variable in this case, it's some new thing, it's just one single constant, so it is not an integer, then it has to be true. If I've said, well, I can only receive integers over this thing, that means that X can only be an integer, which means that I'm sending on things that are only integers, and that is not A.
Totally.
So the JSON schema is a structural type system, but because my language expresses itself, the process itself becomes a structural entity, or it becomes a structure. it's represented in a structure. I then use the structural type system to validate processes. And I'm making the leap to say that that equals a behavioral type system. I don't know if this is true, but that's what I'm saying.
Yeah, I
I have a question.
It's possible.
Yes,
I have a question. So you will need some kind of trace of all the execution paths, all of the possible execution paths. So you mentioned that you can go back, but if you have some complicated process that can branch in different direction, you will have many different outcomes that can happen. So I'm asking, how can you go back from these different different ends?
Yeah, again, like I said, I don't believe that I can detect what the process will eventually reduce to. I don't think. I think that's like the halting problem or something, right? I don't think that's possible.
Yeah.
But
oh no. These will always halt, right? Because they're only nested. The ASTs are only nested so deeply, and they're always reducing to things that are nested less deeply. I don't think there's a halting problem in these calculi.
Yeah, but Joshi, you showed your example that you can self replicate and you can call self twice, right?
Yeah, that's
yeah.
But you can only replicate when you get an external stimulus, right? When there's a message that comes in that says reproduce now. And so if we're treating it as a program that has a start state and then letting it evolve without further input, eventually hey, go ahead and reproduce thing will, yeah.
Yeah, but you can send, when you send me the first input, I will send, when I execute myself, I will send the second impulse.
Yeah, you're totally right. Yeah, you're totally right.
Encoding of the replication operator, basically.
Yeah, great point. Great point.
Yeah, I don't think I can detect what it will evolve to, but my hope here that I'll find is that by having type constraints, I can at least say, well, like I was just explaining, I know that X can never be anything but an int in this example. And so just as the programmer, if you will, I just know that it will never be A, or never be something other than an int, or whatever type I have here. And because the type system is any schema, and I can define really, really deep schemas, I could say a process that has 3 pars, and one of them is this and the other is that. I mean, I can get really as elaborate as to that structure as you want. Then that's the thinking, is that that type system would give us a nice, very expressive system that lets us build interesting programs, because we can constrain using that type system. Anyway, I think the 2 interesting things, I think maybe the type system does give us behavioral types. And then I think that this notion of a namespace being the program, and that the program itself just reduces and reduces, so you have this contained, most of our programs, they run on a platform where like the memory is provided external to us, right? Like it's separate from the program. Whereas here, there's no concept of RAM. There's no concept, right? There's no concept of memory. It's just purely the data model of JSON. And so the program, as it executes, just simply reduces and goes from one state of that JSON to another, to another, to another. And I believe that we can host these, that's what I plan to do, and build, really interesting, you you know, one namespace could be your a Facebook, an individual's Facebook account, if you will, right? These can communicate with each other over the sends and receives, and so all your data is held in your namespace. It could be your bank account, it could be whatever. So you have these self-contained computational units wrapped inside this JSON, and they can communicate to each other over the JSON Pi, or also over the Pi calculus portion of sending names. You know, they all agree that names are sort of global, if you will. I mean, you can create new names, but I mean is you can communicate over names between namespaces.
So when someone send a post to you on Facebook, it will be a JSON, like a JSON file with the one namespace.
Yeah. So there'll be
and
right. Yeah.
You will execute it, and it will reduce in sending on some channel that is your input.
Right. You would listen on your whatever receives messages, right? And then you would send to your friends on whatever name represents their namespace, if you will. Anyway,
Cool.
I think those are the two things that I like about what I'm building here. So
cool. Yeah.
Cool.
So yeah, one thing I just wanted to say is, yeah, I definitely think we can get the behavioral types from the structural types, because I mean that's exactly what I'm trying to do right now in K-Framework. Basically, haven't quite figured out exactly how to do it, but that's what I'm trying to do.
Okay, cool. You know, I am totally ignorant of K-Framework. I don't know what it really does or how it works.
Yeah. Okay.
Yeah, I wouldn't mind seeing an update on that, Isaac, real quick. I got to run in like 20 minutes probably.
Yeah, yeah. I'll try to not take up too much time, but if last time taught me anything, it's that it's always going to take a little bit longer than I think it will.
That's how we all are all the time. So
Yeah.
I'll be back in a second when you're all set. Don't wait for me, but I'll be back soon.
Okay. All right. Well, I'm pretty much ready to go. So, okay. So, what we're looking at here, I'm just scrolling to the top. What we're looking at here is, so I have this, you know, calculus, programming language, whatever you want to call it. I'm calling it GRow for grounded row calculus. So basically I'm basing it off of the row calculus, but I'm also injecting some, you know, Booleans, integers, strings as ground terms. And then additionally, I've added some Rolang ground terms. So I have these collections, which are basically going to be like a list of processes or maps that have processes as keys and values, sets that contain processes, and tuples of processes. And so these are all ground structures, and I can, you know, pass them around just like any other process. So let's see, I'm trying to think of a good place to start. I guess I'll just go through some of this syntax. So, I mean, as usual, okay, one other thing that I'm doing here, and this is mostly just for like my convenience for running some tests, so I don't have to like write out concrete processes every single time I want to generate a name. I'm basically just saying like, okay, you know, I'm going to define these names as one potential instance of a name is it's just like an identifier. So like, you know, X or capital F or whatever, like those are names as far as I care. And like I said, this is just so I can write up simple tests, but basically names come in three flavors. Well, really only two. So they can be like that, just like an identifier, or they can be an actual quoted process, which is what I have sitting here. K-Framework's a little interesting because, like, I mean, you're defining, you know, your syntax through this like BNF-like grammar. And specifically, I'm telling it, I want you to recognize when I put a name in curly braces that it's also a name, but specifically, I don't even want you to generate like a new node in the AST, just know that it's a name and don't do anything in the AST corresponding to that bracket, basically. So that's all this little attribute is doing. Additionally, I have some comma separated name lists, which is basically just for like doing pattern matching for tuples. I don't have this stuff working quite yet, but this is like, I'm like very, very close to having this working. It's more or less it for the names, and then the processes are the usual stuff. Again, I can put processes in curly brackets, don't generate a new node in the AST. Of course, there's like a nil process, that's our stopped process. Those collections I showed before. These ground terms, these are just like, Booleans, integers, strings,
Yeah.
and those are like built in K framework, and I just import them essentially.
Yeah.
I got some arithmetic expressions, Boolean expressions, typical like, eval operator, receive, send, par, all of that good stuff. And then I'm just
show us the diagram.
Let's see. There's a picture on my phone.
Oh, okay. Yeah.
Let's see. Hold on. It's in Discord though, for sure. So let me just get that started up, and then
I would find it really interesting too to see how semantics gets tied into this.
Oh yeah, absolutely. We'll get to the semantics in just a second. So
it's in the same file, right?
Yeah, it's just at the bottom of that same file. Yeah, so I sent a picture to Joshi. Let's see if I can't make that any, oh no, I can't make that bigger. So here's a diagram of all of this stuff that I'm showing you, and basically I'm doing it. So K framework calls each of these, like new tags that I throw in there, they call it a sort. I'm not really sure how sort and type and like all these things relate. They're pretty close. They're not quite the same. But either way, you can draw these nice diagrams from saying something like a name is a quoted process. That basically means that quoted processes are a subsort of names. Because also I can have names that are like just an ID or something like that.
Right.
Either way, my diagram suggests that like quoted processes are a subsort of names. Processes have tons of subsorts, so they can be like stopped process, or they can be a collection. A collection can be all of this stuff. They can be an arithmetic expression. Arithmetic expressions can be any of these things, so on and so forth. And you can do this for all of them. All of these are disconnected only because, like, man, my whiteboard is only so wide, and I realized maybe I should have went landscape instead of portrait, but
Well, and they loop back to what I mean. All those.
I didn't draw any of the self-referential arrows,
Right.
but yeah, basically any of these loop all the way back to like processes essentially.
Exactly.
So this is just kind of like a cool visualization of it, and it's not in its final state or anything, but this is currently where we're at. Okay, that's about all I wanted to show there. So yeah, I mean, typical stuff for like pars and receives. So ultimately, I'll build in some nicer things for my receives, because you see here, like I only have the non-persistent receives, and okay, that's just what I have working currently. The persistent stuff will be in there soon. Same with sends. I only have non-persistent sends, but it's a matter of putting like a 1 or a 0 in a cell, and I'll show you the how I plan on handling the persistent stuff. Everything is more or less straightforward. I mean, eval is just like star of a name. I also included this thing, and I'm not currently using it, but basically this is just a function that's gonna take in a process and then compute the set of free names on that process. I thought I would be doing something useful with that. I didn't find anything too useful, so I haven't done much with it. It's more or less it in terms of the syntax. I mean, for like, arithmetic expressions, we have some of the typical stuff, like I can multiply arithmetic expressions or add them. And the strict attribute is basically going to tell me, like, anytime you see two arithmetic expressions that are being multiplied together or added together, because it's also strict, it's like just evaluate this, each one of these expressions as far as they go, and hopefully that's to an int. And if not, well, we're going to get some sort of error or something. But I've included something that I think is a little bit interesting in here, which is I put the eval operator in as a subsort of arithmetic expressions, and in fact also as a subsort of Boolean expressions. And kind of what I was thinking is this would allow me to do some interesting things. Like, for example, if I had a send that was like with a continuation that was basically like whatever you receive, like turn that into a process and then add 5 to it or something. Like that would be pretty cool if I could receive, you know, like a quoted integer and then take that integer now and add 5 to it, for example. And this actually does do that properly. Same thing with the Boolean stuff.
So you're saying
hard. Yeah.
Sorry, one at a time. What's up?
Go ahead.
Yes, please.
No, go ahead. Tell us.
I want to ask you that this is like a sequence.
It's like a sequence. What do you mean by
you're sending, and after that you're doing something.
Yeah. I mean, I guess so. Really, all I was thinking is like, so if I want to do some interesting stuff in a continuation, like I need to be able to.
That's not a send, right? That's a receive. Isn't that receive?
Oh, sorry. Did I say send? Yeah, this is a receive. I wrote it weird. At first, I was writing it with this kind of more like PyCalc notation, and I've recently started making a transition to the more Erlang notation. But I mean, yeah, it's the same thing. Okay. Yeah, so like if I'm listening on some channel for something, like if that thing happens to be like a quoted integer, like that would be super cool if I could actually like perform this arithmetic with that integer that I receive. And this kind of allows me to do that.
So that I totally agree that's something you want to do. This is an interesting part though, because this is where the type system becomes important, right? Because not every Y is going to make that a valid expression. Only a subset of Ys are going to make that valid.
Yeah, that's a great point. And so K-framework, so it's interesting because like if I were to just compile this and then, you know, like write some program in this language and then tell it to send like a Boolean over Y or something like that, well, it's going to get to a point where it's trying to do a computation where it's like adding 5 to a bool, and it's just going to be like, I don't know what to do with that, basically. And it'll just stop there, essentially. Unless I tell it like, hey, this is how you make sense of adding bools to integers, but I'm not going to do that. But it is one thing that, you know, a person could do. Yeah.
But in your example, this Y, you can say, okay, I have a plus on Y, so Y is constrained to integer. Yeah,
you're saying you could do some yeah, and that would be awesome, like directly from the structure of this term, you could say Y has to be an integer, right?
Yeah, it's the same as you said that Y and int.
Yeah, right. Yeah. So
that's right. Yeah. So
or something.
Yeah, we can use regular old type inference rules here, and then like implicitly apply guarded types to those receives, right?
Yeah.
Okay, so here's a question then, like. Is it wise? Part of me wants to say then, like, okay, so we've done the type inference. We know that for this particular receive, Y has to be an int. Or, well, I guess what we should say is the thing that is sent on X has to be an int.
Yeah, right.
And then, so maybe there's some other receive out there where, you know, it only works if the thing that you get on X is a string or whatever. Yeah. So then should we take our type inference so far as to, like, make it an error when someone sends something that's, you know, not a straight, sends a Boolean on X or something?
Oh, okay. So you're saying like,
yeah.
Okay, so like at some point in time, the thing that this implementation looks at is like the entire like program that you put it in there, right? Like the whole Erlang term, like every, you know, all the stuff paired together. And then it's essentially going to sort all of that stuff into like, if it's a send, it goes into, maybe this is a good time to just show the configuration. So if it's a send, basically what's going to happen is it's going to just throw that term in some capacity into one of these cells that looks like this. So it'll basically take the program that I give it, it'll parse it. This is basically what it's telling it to do right here. So it's going to take that program, it'll parse it into its AST. It'll do a type check or a sort check or whatever you want to call it, and just make sure that I actually gave it a process, right? Like that's what this is actually saying. So it'll take that AST, make sure it's a process, and then once it's that, it'll start doing all of my rewrite rules that I give it. I haven't shown you guys any of that stuff yet. But for example, one of the rewrite rules is it's going to take a send, if it sees a send, anywhere in my program, like as a top level term, so like not nested in a continuation or something. And what it's going to do is it's going to generate what I'm calling a send cell. So it'll generate the cell that has 4 pieces of information. Basically, first piece of information is like, what is the channel I'm sending on? So like if I send on the name X, like X goes here. What is the message? So that's like the process that's being sent. So that'll go here. Is that message a tuple? So like if I'm sending, 1,2, well, that's a tuple. So I'll have to put some information here. And I think the information that makes the most sense to kind of keep track of here is like the length of that tuple, right? Because then I only want it to match with things that, have 2 things to match with, basically. And then the other piece of information is like, is it a persistent send or not? And so it'll be like 0 for it's not a persistent send and 1 for it is a persistent send. Okay, and then
so you got on that because I asked, now that we can infer that we should only be able to send ints on X.
Yes.
Should we, and is it even possible to extend that type system to say like, if the only receive on X expects an int and there's a send somewhere else that sends a string, like first of all, is it even wise to do that if we can? And then second of all, can we?
Yeah, so what I'm wondering is like, should it produce an error or should there just not be a COM that happens in a case like that?
Yeah,
But you cannot produce error.
Yeah,
because you're putting something in a tuple space, right, as a par.
Yeah.
And later you will put another send, which will send.
That's right.
So, guys, I've been using like F#, or I would think that OCaml is similar, if not the same, where it does this sort of automatic generic process where it says, okay, well, we're going to try to leave it as unconstrained as possible.
Mm-hmm.
But when you have that example, like you were saying, where you're going to say you're going to receive something over a channel and then you're going to do an integer operation on it, the type inferencing is going to do exactly what you said. It's going to say, okay, well, if that's true, then this had better be a channel that only sends ints. That only allows ints to pass across it.
Yeah, so Tomislav had a good point, though. Like, imagine I try to send a string, but then it turns out it's okay, because even though right now there's nothing that's going to accept that string, like maybe later in a continuation of a continuation, there's a receive that would do the appropriate thing or an appropriate thing with that.
So what I would say there is that in your for where you match, is you can say, okay, well, you can give it a type annotation that says, okay, I'll accept that anything can come across this channel, but when you get an int, then match and move forward. So there's two cases. One is where it's saying, no, look, I didn't put a type annotation on there, which means I'm accepting anything that comes across the channel. Mm-hmm. And so if I accept anything that comes across the channel, it had better be an int. If I express it differently, that says, okay, well, I don't accept anything that comes across the channel. I only accept the ints that come across the channel. Now that's fine. I think
so like, is that a rolling specific thing, or is that like an implementation specific thing?
Well, so one thing is that your example here is that the channel is X. If I remember right. So that channel must be known to all other parts of the system that send on it. And so they should have the type information of X.
Right.
And so it should be possible that at any location where somebody's sending on X, because they have the type information of X, they can come back and say, no, I'm sorry, you're trying to send a string on a channel that only accepts integers.
Yeah, I like the way you're thinking about that, because we talked about bundles earlier and how you can take a channel and like restrict it to read only or write only, and that just seems like just scratching the surface of what could be a richer language of you can only send ints on this channel, or you can only send things of a certain form. So it would be cool if we could annotate our channels in that way, or like maybe even when you create, new channel, however you do that, create a restricted channel in such a way that it's only a channel for integers or something like that.
Yeah.
Yeah.
So I think
what I've chosen to do is I'm saying, okay, any name can be a channel. And so that's fine, but there will be special names that are actually defined channels that will specify type information about that. And so it's just another name, but it is a special type of name that's acting as a channel, and it will have lots of information that says these are the rules about sending and receiving across it.
Mm-hmm. Mm-hmm.
I really like that idea, because the current like if you look at the grammar for co-op Rolang, they have this thing that they haven't implemented yet that's a guard, where currently we have pattern matching on our receives, right, where I can say like only receive X if it matches the int pattern or something. And what they plan to do is also add guards, I guess, where like only accept X if it's greater than 3 or whatever. But like attributing that information to a channel itself as opposed to a specific receive on a channel seems like an interesting alternate way to do it, because then like if I'm writing a contract that I know I only want ints, then I can just make that channel only accept ints and only give out that channel. That way, since I know that channel's only for ints because I'm the one in control of it and no one else is like putting receives on there, save anyone the trouble, give them a nice compile time error when they try to send a string on it. And then other channels that are used for all kinds of stuff or in a more willy-nilly way, they don't have that metadata that says like this channel can only be used in some way. And then we get the same like, Wild West rules of send whatever you want and hope it comes that we have right now.
Right.
Then you're adding 5 to true.
Yeah, exactly.
But we can also we can have a situation that where this y plus 5 can be the whole process that you're receiving. So you don't have this information about plus. This is like a. You will have this after some other rewrite, because if we have a reflection, this is very similar to dependent types language, where you don't have you will have information about type when you execute your program.
Yeah.
Our like a normal languages doesn't have this capability, because types and values are not the same. Right. But in Roland, we have our types and values are really the same.
Yeah.
Oh, wait. Okay. So say more about that. That seems like an interesting thought. The types and values are the same.
So yeah, in our normal language, F# or Haskell without type families. Type level variables, so type level values, and the value level values are different things, and the compiler cannot you cannot have like a string as a type, or a number one integer as a type, like 1, 2 to be a type.
Yeah, right. Those are values, you're saying.
Yeah, and in independent type language you can say, okay, 1 is a type. 1 as a number.
Are there any popular languages that follow that paradigm? I've never encountered that.
Oh yeah, now Haskell have this ability with type families that I'm using in my implementation.
Oh,
and,
interesting.
Okay. It is
what does that mean? When you say 1 is a type, what's the meaning of that? What are you expressing?
So you're saying that this value 1, you can say this can be my type. And
Right. Okay.
What kind of value have type 1?
You're saying this value is I putting this value in my type level.
So then once you've done that, what kind of things I can, if you say, hey, Joshi, tell me something that has type string, I can think of a bunch of examples. So now I'm saying, Tomislav, tell me something that has type 1. What's an example?
Basic example is you can have a vector, a list which in type defines size. So you can say, okay, I have a list of size 2 expressed in my type. So you can compile your program and say, okay, I will have a list of 2 elements in compiled type.
Oh, okay.
Yeah.
Okay.
So I think this is where I'm kind of excited in my JSON pie, because that's totally expressible in JSON schema.
Yep.
I can say that you can have an array and it has at most 2 items, or min, max, all sorts of stuff. It's very expressive.
Yeah, I'm thinking that in terms of logic on terms, like in Roland when you say and or, you're really expressing logic on your terms in your language. As a type.
Yeah. Yeah, that well, and then I think, because I mean, what really excites me in this project I'm working on is that because processes are expressed in the same way, I can have type systems that talk about processes, and so a process becomes a type. Or I can say I can have a type of process, which is really, that to me, that equals behavior. A type of process means behavior to me.
Yeah, that's interesting, because let's see, I have types that are processes. So type is a subsort of process, I believe, is the way that I've set it up. Or maybe they're totally different. I don't remember.
And Glenn, when you say type as a process, you also mean how you connect processes.
So I can say, like, okay, over this channel, you can send me a process that has 3 parallel processes, and they are all sends. I can express that. I can say those 3 sends, they all must send on channels that are integers. I mean, it goes forever. There's no limit to this. It just you just keep defining and defining recursively like that.
And now is the question: should we be able in with behavioral types express dynamic behavior? So we can say, okay, this program will stop eventually, or it will never have a race condition in this context, or
I don't know
this
how
part
to
of the behavior type? Yeah, I'm not sure.
I don't know how to do that.
Yeah, I'm not sure.
But hey, Glenn, I think we can do exactly that, what you just said, just through pattern matching.
Yes. I mean, yes.
Yeah.
Well, so the type. Well, so I'm finding that the pattern matching and the type system are very much the same. Matter of fact, my pattern matching, actually, whether the implementation actually does this or not, haven't quite decided. But a pattern match actually can generate a schema and then use the schema to validate whether it matches or not. So, for instance, let's say I'm looking for the number 5 over this channel. Well, I can express that in JSON schema. It simply says it must be an integer, or it's even simpler than that. It must be the constant 5. And I can express that in schema. And so that is the pattern match. If it comes back true, then it matches the pattern.
Yeah, see, I wonder how different what you and I are doing actually, because my pattern matching that I'm trying to implement is just type inclusion. Right, so I just have like more general types and more concrete types, and like the concrete types can fit into the more general types given like, you know, some obvious rules basically.
Yeah, I mean, there is the addition of guards. So when you add the guard, that falls out of the schema because it's not a structural. It's not a it's an expression. The guard is an expression. It says do this Boolean expression. If it comes back true, then it matches.
Oh,
So there,
yeah, okay.
but nonetheless, that's okay. That's just, it's kind of just syntactic sugar. Well, it's not that, because it continues to go through the match options if it fails that condition.
Okay. Okay.
Do you a question for Glenn and Isaac, or do you feel that types, in a sense, have some sequencing inside? Because you're matching, but it is always some kind of sequence that you want to comply. I mean, for example, if this is just an integer, you will say, okay, this must comply to integer. But you can be more specific and say, you can say, okay, this must be integer and equal to this number.
Right.
Yeah. And in a sense, this looks like some kind of sequence that you must get to the end. And when you get to the end, you can say, okay, this is okay. This is
well, right. JSON's, I mean, you mean that there's a dependency on the order of evaluation?
Yeah. But you're saying type must be this, and this.
Well,
it's you've defined the constraints by combining other constraints, right? A and B.
Yeah.
I mean, so I guess yes and no. It's not necessary. Well, so first off, with matching, there is an implied, lexical order determines the order that the match expressions will be evaluated, and that's needed because you're not guaranteed that they're distinct, that they're what's the right term? That it can't hit multiple. They're disjoint. Mm-hmm. You can't guarantee that the match expressions are disjoint. Yeah. Meaning, if you don't evaluate the first match expression followed by this, and see if that comes back true or false, followed by the second one, followed by the third one, it could be that it matches two of the three. How would you choose which one?
Yeah, exactly.
I mentioned, and that's a really common pattern actually, is to say, okay, match with this very constrained item, like it has to be the number 5. And if it's not the number 5, well, maybe it's an int, and I'll deal with that. And if it's not an int, I'll throw an error, right? So there's a case where it could match all 3. 5 is also an int, and it also is anything. That's how you write the third expression, to say, okay, if it's anything, meaning it didn't hit those first 2, then throw an error. Well, 5 would match all of them, so you have to evaluate them in order. Yeah, and that's part of the language. That's definite. That's defined in the semantics of the language. The programmer has to know that, and it has to evaluate that way. When you're saying internally, whether we say there's a sequence, like if we look at JSON schema, the vast majority of the constraints could be done in parallel. I don't in my implementation, but a lot of them could be done in parallel. They are not dependent on each other. They do traverse the tree, and for instance, you can define a default if you saw that. So that's dependent because you have to evaluate that default before you can continue the rest of the evaluation, because you want to check the default that it's valid. So there are some dependencies, but for the most part, they could be run completely in parallel. And if they all come back true, then it passes.
I see.
I think what
yeah,
you're
but my question is more.
One thing in Rolang that I find different, well, it's so different from what I'm doing in JSONPy, is that everything's a process. And that for me is really hard. It makes the problem so mind-bendingly hard. Whereas that's not true in my JSONPy. It's a very constrained set of all the possible names that are processes. And so it lets me be like really focused and doesn't drag me into too many blind alleys where I'm like, oh gosh, what would that mean? You know, because otherwise it would just become a name, and I'm like, I don't care. Anybody can send on any name, or be it, you know, I don't care about names. It's just data. But my processes I can be pretty strict about. And in Rolang, it has to, everything's a process, and you're like, oh no. So when you get to this sequencing, that's where I think maybe your question is getting to, because of the nature of the language that you've been, you know, working and thinking in. I can't be more concrete than that.
You mentioned that, yeah, you can do this in parallel, which means that you're deleting this distinction. You can express type as a list, but semantically they are the same, although the definition can be in different order. The two types expressed, it must be written sequentially, because you.
Yeah, well, because of the language, when you're talking there, you would have to, you know, just like a match expression, I'm sure in Rolang, the first one goes first, and then the second, and the third, and the fourth. You have to have that. What I think you're getting at is a little bit, is like when you decompose pieces, when you're sending processes around and you're decomposing them, they can be in parallel and all the rest, and it adds a lot of complexity. I think that's where your question was. That's how I was kind of reading your question. In the end, like for like when I was talking about these conditions, like, is it an integer and is it the number 5? Well, I don't know that I really care if those happen sequentially. Maybe I'm missing to me, I'm kind of okay that they happen in order. But if it's expressed in the language, if that's exposed in the language somehow, and your language is, you know, everything's a process and they can be decomposed and stuff, well, then I think it gets torn apart and it gets kind of, I don't have an answer for you there.
Yeah, and I guess I'm thinking, like, if I wanted something to specifically only match the integer 5, I would just tell it to match against the integer 5 instead of saying, like, is it an integer? Yes. Okay, now is it 5? You know, like, you just match against the concrete process that is the integer 5, and there's only one inhabitant of that you know, type or whatever.
Yeah. But you will definitely say that if I wrote type as an integer and 5 is the same as just say and 5.
Oh, you're saying,
semantically you will say, okay, this is the same definition of type.
Yeah, I think we could just do something reasonable like that. Yeah. I'm not sure. I haven't gotten quite that far, but I think you could do something reasonable like that.
One of the things I'm going to do, and I haven't done this yet, is part of type inferencing is to figure out the domain and range of every expression.
Yeah.
And so you could have a type that says it has to be an integer, and it has to be 5. And if you figure out the range of that, it is only the number 5.
Right.
And if you have another type that says it just has to be 5, it doesn't say it also has to be an integer, well, its range is also just 5.
Yeah.
So you get your type, I believe then your type inferencing comes back and says this is fine. They're compatible because the range is the same.
Yeah. Right.
Yeah, this makes sense. Yeah.
Yeah. Cool.
Sorry, Isaac. I was.
Yeah, that's okay. We were talking about some interesting stuff there. Things that I haven't fully thought about. So it's good to get that opportunity. So let's see. So I think I was saying what all of this stuff in the send cell does. Okay, and then like another aspect of this, right, is that so this is XML. Like this is the only XML stuff I've ever done is in K framework. But like this color is like totally useless. It's just for displaying it in terminal when I actually like run a program. But the multiplicity part is important. And this multiplicity equals star is basically just telling me that there can be 0 or more of these particular send cells. So like, and that's intuitively very clear, right? Because like the tuple space could have absolutely no sends in it. So there are 0 send cells in that instance. There could be 20 sends currently occupying the tuple space, and maybe there are 20, cells that each one represents one of those sends. So it's a similar thing with the receives. And so again, like I'm just, you put in your program. I'm not, I guess I'm calling this grounded row calc or something. So like I put in a grounded row calc program, which is just a process. And so it's gonna parse that into the AST and then basically, fill these send and receive cells. So we're doing the same exact thing for the receives. Like there can be 0 or more receives, intuitively clear. I need to keep track of several pieces of information. So like what channel am I receiving on? Like what thing am I trying to pattern match against when I do my receives? And so I think something in here can guard us against doing something like consuming, like a bool message for something that needs an int. I think that can be done just on the level of these cells. I don't think it should be a problem, but I'm not 100% sure. So I'm calling this like the binding variable. So this would be like I don't know. Earlier I wrote like a receive that was basically like for y from x. This is your y basically. In fact, since we're doing like tuple matching, we can have multiple binding variables, and that's just to like keep track of what coordinate, each. So like how many coordinates do I have, and then I'm going to have to keep track of like which one is binding to which coordinate in the tuple. But that's what this cell is. Like if it's just one variable like a y or a wild card or something, this would be 1. But maybe I'm trying to receive specifically like a 2 tuple, so I would need to know that there are 2 pieces of information here, and so like I would put a 2 or something.
So one thing you might think of is it's the more general pattern or general form is that you have a pattern on the left and an expression on the right.
Yeah, right.
And then patterns can be of many shapes and sizes.
Yeah.
And one thing that I've come across is that you get bindings out of that pattern process.
Yeah, right.
So you can get many bindings.
Yep.
Well, that's what I'll have.
Yeah, I mean, yeah, so that's what so there will be an integer in this cell that keeps track of how many of those bindings I'm getting out of the pattern that I'm matching against.
Okay.
Yeah.
Well, okay. So for me, I'll like patterns can be made of patterns, so it's recursive in that sense. Okay.
Yeah. Yeah, and then also there's a cell for like if it's a join. And if it's a join, I haven't implemented this in any fashion yet. But if it's a join, basically what I'm thinking is like anytime I see a join, I'll just like generate a new fresh integer that'll just like be a tag in this collection with like each piece that I'm listening for, each channel that I'm listening on, just so I can kind of know that like all of these were a part of the same join, and then like maybe all of these were a part of some other join, and like these ones there was no join. Like I said,
one thing with join is I'm just starting to work on this, but
yeah, same here.
I think for me what it will be is that is the word cleany star, or it's a cross. So what I'm going to do is I'm going to create. Is it the cross join? Anyway, when I have a join, I'll create so okay, so if you're joining A and B.
Yeah.
So I take the first name from A and I pair it with all of the names from B.
Okay.
Okay, so on A you could have many different sends, right? There could be a dozen sends on A and there could be 10 sends on B.
Yeah.
And so you have to match those pairwise, you know, the first A with the first B, and then say, okay, does this match a pattern?
Yeah.
And then the first A with the second B, does this match the pattern? And so on and so forth. At least at its, there's optimizations of this. I would, well, I'm not going to get into the optimizations, but I don't know them. I'll hope that I plan to actually implement it on top of like SQL and let SQL do the optimization.
Yeah, I'm not too concerned about optimizations currently. I want a working implementation, then I can focus on optimizations.
Yeah.
Words. Yeah.
But I think that what happens is then that actually I believe that anyway. That's what I think it means. You have to do all those combinations and match and the first match then wins.
Right. Okay.
I'm sorry. For each
you must. Oh, sorry.
For each rule, you must go through all the combinations, and then you can move to the next rule.
Wait, when you say each rule, you mean like each listen that's in the join?
Yeah, sorry. My language, on the listen I give multiple rules. So it's a match and a listen at the same time. So the for comprehension isn't just one thing, it can be many expressions.
Oh, okay. Yeah.
This is like a join in for.
It is yeah,
right?
So it's a join, yes.
When you put yeah.
But the conditions you apply to the in the for comprehension, like, oh, it has to be an integer and so on and so forth, the join is just on the names, but the conditions are like the where clause of a SQL. So if you're joining across two names or two channels,
right,
then all of the values that are on those that have been sent, because people could have sent thousands of names on that channel before your send is being evaluated, or actually on your receive is being evaluated.
Yeah.
When your receive is being evaluated, you might have to contend with many thousands of names that have been sent on those channels.
Right.
And finally, only one you get a match, right? That meets your conditions.
Oh yeah, because of conditioning that you might have done. Yeah, that makes sense. Right.
Right.
Yeah.
So as I've thought about it, you have to go to each rule. Well, in Rolang there is only one rule.
Right.
But evaluate it against every one of those possibilities, or rather, grab the first one that meets it, because that's all that matters.
Right. Yeah. So I think if, I can probably put some sort of, add one more cell to each of these, like send things and receive things, that's doing this, like, if I have some condition, like I need to be sending an integer, whatever, something along those lines, then I think I can just have a cell that will basically tell me, like, okay, this has to be of type int. And then I'm only looking at like the receives that are taking type int, basically. But like I said, I didn't even start thinking about this until literally this session talking about it. So I have no idea how that will be implemented, but I think it could work.
Yep.
Okay, and I mean, that's basically it, right? Like I need to say whether that receive is persistent. If it is, I keep it in the tuple space. If it's not, it gets deleted. And then obviously I keep track of the continuation. Yeah, so I may need to add some stuff here for like conditioning on sends and receives, but that's not there yet. See, this is just like, you know, arithmetic Boolean expressions, how they resolve. That stuff's all straightforward, but this is the maybe less straightforward or more my choice and less standard thing. So the way that my par operator works is like, what K-framework does is once I define this configuration, so here's my configuration. I've defined the configuration, so it'll always start off by parsing the program into an AST. It'll check that it's a process because I told it to check. And then it will populate one K cell with that AST. And then it starts doing all of these rewrite rules that I defined below. Everything else, so these .ks in all of these cells, basically just tells it like there's nothing there initially. And if it has to do, so K-framework does something called configuration abstraction, which is basically a convenient tool so I don't have to specifically cite every single one of these cells that appears in my configuration every time I want to do a rewrite rule that contains any cell whatsoever. So basically, if I do a rewrite rule and for whatever reason it only operates on this send channel, I can just tell it what it does in the send channel. So like, for example, I'll show you. So there's one pretty obvious thing that you might want to do, and that's like if you were to ever see one of the threads, which I'll explain above, that's totally empty. There's like no computations to be done. Well, why keep it around? Like, let's just get rid of it. And that's essentially what I'm saying here is if I ever see a thread that's empty, like regardless of what else is going on in my configuration, dissolve that cell basically. And a similar thing is like if I see a thread that has literally one process in it and it's the nil process, like go ahead and delete that as well. Like that's useless. There's no computation happening from that.
This is like a garbage collection, right?
Yeah, basically. This is just to like make things look a little nicer.
Well, actually, garbage collection is an interesting. To me, garbage collection means getting rid of sends that will never be received and getting rid of receives that will never match a send.
Oh, but we couldn't do garbage collection ruling, right? Because like those may come up at some later point in time.
But if you listen on some unforgeable name that you never send to anyone, this is impossible to receive.
Yeah.
Yeah, well, especially when it's tied to a blockchain, that's even more interesting. What does it mean to collect garbage since the garbage is in blocks that are, you know.
I mean that you as a validator, you can delete this data and not pay for the storage.
Yeah. Right. Sorry, yes, right. For future blocks, yeah.
No. For existing block. Why you should not?
And then subsequent blocks.
Yeah.
Well, yes. So I've been thinking about that. I think that. I plan to be able to close a namespace, and so that means that it says, well, there can no longer anything it's listening on it's not going to listen there anymore, and anything it's sent. Well, I haven't exactly thought the semantics through, but I do plan to have garbage collection where, yeah, I'll have to think. I have some ideas on being able to do that because it's really important to be able to clear up. Actually, one thing I thought, because my language is sequential, it's synchronous from like after a send. I'm sorry. What I'm planning to do is, I think, add syntax that says, well, if it didn't match a listen, don't keep it. I haven't thought this all through yet, but I think I'm planning to have a deterministic evaluation order. Because right now, Rolang is just totally, they intentionally want the evaluation of pars to be non-predictable.
I thought there was a normalization thing that they're using. Which I don't understand. I don't know how it works, but there's supposed to be some canonical way of sorting it, you know, a par so that you're going to process it sequentially. I mean, I don't know. I haven't looked into it too much. I just heard that this is a thing.
Okay. Well, my understanding was that they intentionally randomized the execution order of pars so that there would be no meaning and no expectation on the programmer's part that it would evaluate in any given order.
Yeah, so that was my original understanding, which is why my par operator has the semantics that it does. So I mean, so basically what it's doing is anytime I find two processes in par with one another in a computational cell, what I'm going to do is spawn two thread cells that each have one computational cell in it that just contains individually those processes that appeared there, and then just delete them from their original appearance. So anytime I have a par, it's just going to, you know, if I have a par with 5 different things in it, all 5 of those things will individually go into their own computational cell. And this is nice because K-Framework actually has truly concurrent semantics. And this is like one way to enforce truly concurrent semantics is throw everything into its own individual computational cell, and it'll treat them as concurrent things.
Right.
Yeah. So that was my understanding, and that's why I implemented, you know, par the way that I did here. And yeah, I mean, like all of this other stuff is, you know, exactly what you would expect. Like anytime I see a send in a computational cell, what it's going to do is dissolve it and then just, you know, process that information the way it needs to. It'll create this corresponding send cell in the tuple space, which will, you know, contain like the channel, the process that was sent as the message. In this particular example, I'm sending in like a legitimate canonical process. It's not a tuple or anything like that. So I'll put 0 for a tuple. I'm just saying processes are 0 tuples, and it's not persistent. I think there may have even been like some other cells that I need to add here. I just haven't added them yet. But either way, this is like the semantics of my send. Is it just generates something in the tuple space? I didn't say how comms work yet, but this is essentially all that it's doing is like, you know, processing the computational stuff and then making these tuple space cells that correspond to those computations. And like for one tuples, exactly the same thing. Now it's, you know, a tuple that has one coordinate, you know, all of the other information is exactly the same. And then this is the, you know, for if I'm doing an actual send of a tuple, the way that I'm characterizing a tuple is it's like multiple processes that are comma separated in these, you know, parentheses. And essentially it's going to do what you would think. It's just going to take all of the processes that are in that tuple, throw it into the message, and then specifically so I can like, you know how many names I need to find to bind to, I'm also going to store the length of this tuple here, which length of a tuple is like exactly what you would think it is. If I, you know, put a 1 tuple in there, it gives me a 1. If I put a 6 tuple in there, it gives me a 6, right? And it's not persistent, so it gets a 0 in that cell. I don't have any of the persistent send stuff yet, so there will be like, you know, these 3 rules will have exact mirror images, all with like double exclamations and a 1 in the, you know, persistent send cell. Basically same stuff with the 4. It's just taking, you know.
Sorry. Can I ask you about the send? Why do you need special treatment of a tuple?
What was that?
Why do you need special treatment when you send a tuple? Because tuple is also a process.
Okay, so it's a little bit weird, right? Because a tuple is a process. So if I were to, so this is totally stupid, but if I were to do like x send the tuple 1, 2, this puts me into this first situation because a tuple is a process. A tuple, so here I'm actually sending the process that is the tuple, but this is different than sending the
I see.
1, 2.
This is not a tuple, really. This is like two processes, but not a tuple.
Yeah, exactly. So this is really just like sending two processes. Yeah, exactly. Yeah, so the language is a little finicky, but it's okay as long as we understand each other.
Oh, yeah. You're sending two processes.
So a tuple is itself a zero tuple, if that makes any sense, right? Because a tuple is just a process. However, if I were to send, like I was saying, like 1, 2, I'm actually sending two pieces of information here. I'm really actually sending like a two tuple. And that would land me in this situation. And basically all I'm saying is I need to remember that I sent two pieces of information because now I need two binding variables basically for a receive. Yeah, and I was really happy I got this length function working. Everything should integrate and work now, and hopefully I can even do some tuple matching. But the problem with tuple matching is it gets complicated for the substitutions that you're doing, because now if I'm keeping track of like this piece of information matches with the first variable that I'm matching, and then this other piece matches with this other thing, I have to create a map of some sort. And then, you know, apply the appropriate substitutions according to that map, but I haven't gotten that functioning yet. Yeah, similar thing for receives. So if I'm just listening for one specific name, variable, binding, whatever you want to say, then essentially all I need to keep track of is like that's the only thing that I need to match if I were to consume this receive. However, if I have multiple things that I'm trying to match against, well, I need to remember how many of those are there. So if there's like 2, well, then I'm matching against 2 tuples, and if there's 6, I'm matching against 6 tuples or whatever.
Do you need really this first definition? Because length, if you only have one, it will return 0.
Yeah, so there's like a totally stupid thing which I'm sure I can get around, but anytime I say names, I literally mean 2 or more. And anytime I say name, I mean just 1. But yeah, I mean, it's totally done. Like I could put length, of Y here, but of course length of Y is just going to be 1. So I just put
you're using different syntactic construct. Not name, but names. Okay.
Yeah. So just real quick, right? So it's silly, but I was getting some errors doing it a different way. But names are specifically 2 comma separated names or more, basically. And then similarly with the procs, these are 2 comma separated processes or more, basically.
I see.
Yeah. And I was getting some weird, I think they're calling them assertion errors when I was trying to do sends and receives with tuples and processes. I don't know, this fixed it, so I'm happy that it's now working. And I don't have com rules for everything yet, but specifically if the message is a process and like not a tuple, then I have a com rule pretty easily defined for that. And it's exactly what you would think, right? Like basically you're just checking in the tuple space, is there a receive cell that has, a receive on a particular channel that matches, a send channel, whatever that variable is that I'm going to bind to, and whatever the message that I sent, well, I do the appropriate substitution in the end when I do my continuation. That's basically it, right? Like if I have a receive with, on some name X, and I have a send on some name X, and, there's only one name that I'm trying to bind to, and this is either like, one, how do I want to say this? And so, yeah, I'm just sending a process in this particular case. I'll have to do it for if specifically I'm sending tuples or whatever. But either way, I have it working in this case. And this substitution works exactly the way that I want it to. However, once I get to more than a 1 tuple, it starts to become complicated because, like I said, I need to keep track of like which coordinate of the tuple gets bound to which variable and etc. And that's not something that I've implemented currently.
And this is the syntax for substitution.
Yeah, so this is just saying like whatever that, so this is saying whatever the continuation P is, take that process and then substitute the name at Q for Y. Yeah, so Y was my binding variable and Q was my message. So I want to substitute at Q for Y in that particular process. And so K-Framework can do this, like you can, substitute one name for one name, or you can actually give it a map of like keys and values and it'll do all of those substitutions at the same time, basically, which is what I'm thinking I will have to do for tuples, but I'm not 100% sure because I don't know about uniqueness of keys, but it's okay. Yeah, and I think that's more or less it because I showed you some of this, like just cleaning up computationally meaningless stuff, quoting and evaluating our inverse processes and row length. So these rules are applying anywhere. If I see at star a name, it's just the name. If I see star at a process, it's just the process. That's pretty much it. I commented all that stuff out, but
cool.
Yeah.
And you only need a number of bindings. So you don't store the pattern because you don't care about the pattern. You just care about how many bindings.
Yeah. Well, so the pattern will ultimately get stored here. So if I'm listening on some channel for two quantities like X and Y or whatever, then I would literally put like X comma Y here, and I'll know that I'm listening for two different things, and that could only match against a two tuple, and whatever I would need to do from there. Yeah, so not a lot of all of that is up and running, but I currently have a way to think about it, and I think a way to implement it all fairly soon. So hopefully next week I'll be showing you all of this, and I'll be saying, oh yeah, all of this stuff is now running. Let me show you some examples. Like here's this super cool substitution of tuples that I'm doing, and all of this stuff. So that's the hope, at least.
Cool. Looking forward for that.
You too. Yeah. And then Glenn, I know you weren't here around last week, but I was showing them the structural type system that I have for I guess, boy, it's grounded row calculus with patterns or something. I'm not even sure. I've done so many different implementations that are just like slightly different. But yeah, I have like a nice working structural type system, at least for like that grounded row calculus with patterns. It's not like full scale rolling, but it could be modified to handle full scale rolling, I think, pretty easily. Okay, cool. Yeah,
it's really interesting to see the K framework here.
Yeah.
I don't fully grasp all of its syntax for sure and what it means, but I definitely see how it maps to, well, basically how you build a compiler. So
yeah, cool.
Yeah, that's great. That's awesome.
Yeah, awesome. Yeah, thank you for showing your stuff too, because yeah, it was like surprisingly similar to some of the stuff. Well, I at least I think it's surprisingly similar to some of the stuff that I'm doing in K framework. So that's pretty cool.
Yeah. What does this ultimately build? Does it like generate Java code or something, or what is it?
Yeah, so I mean, it generates a K definition. So you see, I'm just writing this K file, but basically this K definition is a programming language. So I'm trying to like do an implementation of Rolang that has formally defined semantics, and then K has like prover tools and all sorts of interesting like model searching tools that you can use to like prove theorems about your formally defined semantics and all sorts of things. Like it has so many tools that I'm not even aware of yet.
Interesting.
Yeah.
Because I'll end up defining my rules as like, okay, it meets this, it passes this schema, so it has this structure, and so anything that goes, so there'll be transitions that just simply say, okay, when you see this, it goes to that.
Yeah.
Which is kind of what your rules are doing. That's what your rules are doing.
Yeah, exactly. That's exactly what these are doing.
Though do these rules happen in sequence? Does order matter?
So like I was saying, K-framework has truly concurrent semantics. So the fact that I'm taking my all of my pars and basically like destructuring each parand or whatever into its own computational thread, all of these computations can happen concurrently, and you can actually do like a search of all of the possible reductions out of like a given program.
But does the order that you define the rules matter?
No, that the order that I define the rules doesn't matter.
So they have to be disjoint. They can't. Yeah. You can't have two rules matching the same condition.
That's right. It's a little bit annoying, and that's, I think, what you're getting at right now is the issue I was having when I was letting procs consist of one process or more than one process, because it was trying to match as if it was a process instead of a list of processes, and it was giving me some weird stuff, which ultimately led me to say, well, procs are two or more, and a process is just one. There's probably a way around it, but that was the easiest solution I could come up with.
Okay.
Yeah.
Okay. Well, cool. Thank you for showing that.
Oh yeah, absolutely, absolutely.
Yeah, this is super helpful. Yeah.
Yeah, cool. All right, great. Yeah, like I said, hopefully next week I'm showing you how well all of it's working now.
Cool.
Yeah. All right, guys. Yeah, Glenn, thank you for showing us your JSON stuff. I'll stop screen sharing, and yeah, I probably need to get going and trying to make that goal of working implementation next week a reality.
All right. Yeah, sounds good. I need to run too. Hey, good to see you guys again, and nice to meet you, Isaac. I think this is the first time we've seen each other, Isaac.
Yeah, it's nice to meet you as well, Glenn.
Great.
All right.
Take care, guys.
Glenn, what do you be with us next Friday?
I hope so. I think I'll be around. I think I can.
Cool.
Okay. Great. Take care, guys.
Take it easy, everybody.
See you. Bye. Bye, Jim.